not ants. So I'm excited to share with you today some of our ongoing work using Motus technology and how and why we incorporated a modified version of this technology into our work. Alright, so I'd like to start off by introducing my collaborators. I can't overstate how much of a team effort it is to run projects that use Motus technology. You've heard a little bit from a few of our previous speakers about the Motus network in general and how much work goes into number one, creating the towers and then maintaining them. So it's kind of an interdisciplinary tool. It requires ecological knowledge of the set of species that you're working with, a certain understanding of engineering and construction, as well as the IT hardware and software side of things. And I don't really think one person can kind of have all of those skills in their entirety. So it's great to have collaborators, amazing collaborators, that you can kind of put your heads together and make things work with. So in no particular order, we've got Christina Davies. She's the field leader at our lab at Carleton University and is our lab expert extraordinaire. We've got past postdoc at Carleton with the Navy Lab and current postdoc at the University of Saskatchewan, Dr. Lisa Elizondo, and she's an expert in all things Motus, especially on the software side of things. And then we have Toby Thorne, who many of you know, and from past back meetings. He's the supervisor of species at risk recovery at Toronto Zoo, and he helped establish the native conservation bat program where he first implemented some of the Motus modifications that I'll be talking about later. And finally, Dr. Erin Secondwoods is a current postdoc at our lab, where she spearheaded projects for the last 2 summers using the Motus technology and continues to mentor students in Motus data analysis. All right, so we already heard a little bit about this, so I'll kind of breeze through this a little bit. But I just want to start by pulling back for a moment and reminding us about some of the general telemetry tools that we use and tell you why we felt like we needed a modification of these. So handheld very high frequency telemetry, or VHF, has long been used to track wildlife in real time, offering insight into behavior and environmental interactions. So it requires going out on the landscape. You're listening for a radio signal that your already tagged animal is emitting in the area. And then it's kind of like a game fog. You're getting closer to that animal, trying to find its exact location. And like you've heard, like Derek said, don't often get the animal always, but usually we can get it down enough that we can say for sure they're in that tree. Okay, so it typically incorporates a Yagi antenna, like I circled there. Also incorporates the use of, in Ontario, a low-tech receiver. So this is a handheld receiver. You can see using the receiver, it's attached to a coaxial cable, which connects to the Yagi antenna, and we'll be looking for that So I mentioned previously that with my MSc, I worked with Christina and worked on snake health, and we actually employed VHF telemetry within those studies, and it was quite successful to search for snakes that use a relatively small range out of Frenchel Park and find where they were on the landscapes in those times. However, tracking can be very manually intensive, labor intensive, and limited by the distance that researchers can actually travel. So that's why bats in particular can be a challenge to track due to their small size, which limits the types of tags they can use, and also their unique ability to remove these tags off of their backs, whether that's themselves or their friend getting them help to get the tag off. And this happens generally within a few weeks. We have a very short window of being able to track these bats because of the battery life of the tags, but in addition to that, the bats being able to remove the tags themselves. For the snake work that I did, we actually sewed them into the bodies of the snakes, so that's much harder to control. So in addition, the density of the tags in an area is also a big challenge. And if you wanted to say tag 100 bats from one colony, at the same time, you could have a bit of a challenge with that. There'd be a ton of overlapping tags and beat frequencies, and the amount of physical tracking to do something like that would be very labor intensive, working on the possible. Oh, that was my bad. Nice. Okay, so to address some of these issues, the Motus wildlife tracking system, also known as Motus, can be used. It was initially developed for birds as an international network of stations, automated telemetry stations that track tag wildlife over large areas. So you can see in this map here, this is And then on the slide over here, you can see a bat that has, you can't really see where its actual tag is, but it can kind of be nestled right in between the shoulder blades. And then on the back of that, you can see the antenna from the tag, and that's how we pick up the frequency. Okay, and then just because I mentioned it, so we said that the bats are actually able to remove some of their tags off. So here's one of our caught bats after this tracking period, in which I can remove their tag off. And you just see where we put it in between the shoulder blades there, that there is left a bit of a bald spot, but otherwise, that's okay. So here's an example of what a traditional Motus tower looks like. While it's effective for long-distance migrants, it provides limited insights for regionally migrating species, like some of the bats we have here in Ontario. And this can be due not only to its broad detection ranges of the ABN antennas on these towers, but also because of the limited leaf station locations. Certain areas of the world have lots of stations, other areas they're a bit more sparse. That being said, so Motus can provide some relief in terms of tracking on foot and capture unique snapshots of that movement. Over the last 8 years, the BU Lab has incorporated this Motus technology into projects across Eastern Ontario, and we've constructed over 15 Motus stations to add to them. Okay, so we did have to notice some challenges when using this technology with many of our Ontario bat species. So like I said, the Motus network is limited to where the towers are contained, and where they're placed and where they're maintained. And this is especially clear in Ontario. So this is just kind of like a very simplified map. Basically, you've got a lot of stations down in the southern end, and then you can more sparse as you go north. And even when you have them in kind of like centralized areas, like where it seems like they're clustering, they could still be many kilometers apart from each other. So it seems like we could be losing data to geographic coordinates in our Motus networks. And likely, again, this is just a product of the cost to construct and maintain these stations. They can't be everywhere. So, in this case, the range of these towers may actually be too large to provide us with useful information about habitat usage, especially with bat species that have smaller home ranges. Finally, bats also fly low, sometimes they can be completely missed by these large towers. In this example, a bat, such as a big brown bat, may be in a tagged area, the area with the Motus tower. Let's say he's pinged off this single Motus tower in southern Ontario, and flies off, but he's not picked up on any other Motus tower. So we can't actually get much information from that one piece of detection at one Motus tower. And it limits some of the inferences that we can make. Sorry, I repeat this again. Okay. So we attempted to fill these gaps by using a modified version of the traditional Motus technology. And while this technology isn't new at all, it's been applied to a variety of studies. This is one of its newer uses in regionally migrating bats. So Toby Thorne from the Toronto Zoo has been since called these smaller Motus stations as mini Motus, and they're substantially smaller than our regular Motus stations. So just to remind you, so we've got a big Motus station in the center. It could take a day, maybe more, to set one of these up. You need a pretty large team. But then these smaller Motus towers, the mini Motus towers on the side, they can be set up ideally 10 to 20 minutes if everything goes according to plan. And yeah, they're much easier and they're portable. You can take them off the landscape very quickly, drop them off in any place. Okay, so let's go back to our Motus map of Ontario from the onside view. In the previous example, the tagged bat is only detected on one traditional Motus station. So let's say that traditional Motus station is close to a known hibernacting site or maybe a returning roost. That's not a returning roost, so maybe so using a mini Motus, we can now kind of pepper this area with smaller towers, and it's a grid formation, and that can and use that to interpret movement patterns and foraging habitat, which is exactly what we did. So I just like to take a moment to shout out our private landowners that let us post all of the mini Motus on their landscapes, in their backyards, into their house, and also track throughout their properties. It's a huge ordeal, and just for kindness and niceties, it made it a lot easier to do that. So we think we do. And this has also allowed for some unique bat outreach opportunities and created lasting ties between our lab and collaboration with Toby and Sean's team, and she studied habitat of big brown bats and northern Motus in the Rouge National Park in Big Brown. We knew from Toby's previous work that there are northern Motus in the Rouge forest, as well as big brown bats, but that forest is surrounded by a heavily urbanized area, as many of you know, and it includes the highway around lots of commercial development and residential areas. So the next question that we're going to ask is, how relevant are these two species, or how reliant are these two species on the forest in the Rouge? And will they also use the urban habitats for foraging? So they went out and deployed an array of mini Motus stations in the forest, in people's backyards. Again, shout out, thank you to our backyard folks. And here we go. Here's what we got. All right, so you can see the detections for northern Motus on the left, big brown on the right. Towers that didn't pick up the bats, that didn't detect bats are shown in orange, pink, or purple. And then the towers that did detect the bats are shown with the back lines. So you can see that the northern Motus were only being detected on forest towers, while the big brown bats were also being detected on urban towers. So both urban and forested, where the northern Motus was only in forest areas. You can also see that although the big brown bat are detected in urban habitats, they're also heavily used in the forest. So although they're more tolerant of urbanization, they do still rely on the forest within the urban habitat. And similarly, in another example led by Dr. Aaron Stickenholtz, we were able to track concentric movements of tricolored bats, which are regionally migrating at-risk bat species in Ontario. And like in our example, she used an array of mini Motus, only this time focusing on foraging habitat between moose. The use of smaller omnidirectional antennas provided increased resolution and frequency in these local areas. Using this novel approach in combination with handheld radio telemetry, we were able to gather otherwise unobtainable data on bat movements in and around critical habitats such as maternity roosts and hiring. Something that Aaron is also doing is highlighting unique social interactions, creating social networks between individuals like shown here. Preliminary data shows that juveniles travel with adults, but group size and composition can shift. So Aaron will be presenting another aspect of her research tomorrow, so please tune in. More recently, master's candidate Aaliyah Amba, who is in the square here, has further modified this mini Motus system to focus on directional movements in big brown bats at an anthropogenic maternity roost as seen here. So these ones are slightly more modified. They have, in addition to the single omni antenna that's at the top of the mini Motus station, circles here, she's also added these directionality components of handheld gadgets to the set. And you can learn more about her work by visiting the poster and chatting with her throughout the months. Okay, so while mini Motus has addressed some of the limitations of traditional Motus technology and manual VHF tracking approaches, oh my gosh. While mini Motus addressed some of the limitations of traditional Motus technology and manual VHF approaches for small-scale tracking, it's also involved challenges such as variable detection probabilities between stations and data processing issues. While managing both traditional and mini Motus stations require technical expertise, here's Lisa with all of her technical expertise, and infrastructure, it can be costly and there's unique challenges that were associated with this mini Motus approach. And then here's me with some technical expertise. So Dr. Lisa Zondo recognized the need for calibration tests to be done for each of our mini Motus array setups. And this was briefly touched upon with Derek's presentation as well. Basically, you need to test out all of the equipment you're going to be using. You need to figure out how wide the range is for detection pickups of your tags. We had tags tied to balloons, drove them around the city. It looked crazy, but that's how it gets done. This test emphasized the need for using test tags in your work and ensuring that the stations are working correctly and to document detection variabilities among stations. Manual tracking can also help as a verification step in increasing confidence in the arrays. We also ran into several obstacles that originate from the portable nature of the system. So while the big Motus towers are continually on the landscape, and yes, you can run into issues with like powering, if you're plugging your stuff, it's it's shading over top of your solar panel. With this mini Motus, it's actually the physical movement of the boxes that we think is causing some issues, so it's jostling parts around. You can't then recognize easily what's become undone or missing. You have to buy new parts, fix those parts. And it requires a sort of kind of technical expertise to understand what's happening in the components of computer parts that stop working. So this can become costly and requires a certain level of expertise. So the constant on-off nature of these stations is, again, we're moving them, we have to depower them down and then move them, power them back up. It's also created issues on the data processing end. I won't get too much into the weeds here, but basically it causes a delay in data showing up on the Motus website. So if we went and we did this array setup, we're so excited about looking at our data, we go into the Motus website, the data's all uploaded. Oh my gosh, we have to go back detections. If we wait a little longer, they do a rerun of the data, then they start filtering through. We're still working through some of the logistics of that and why it's occurring, but for now we've got a bit of a workaround. And this is basically just a product of the Motus system's extreme dependence on correct metadata for tax distinctions. Okay, so with all that being said, when this works, it really is epic. It's important to be upfront about some limitations and potential detection biases that we could be experiencing, but it really doesn't negate all of this really cool work that's happened with backlinks like the deeply Motus networks. I'm excited for you all to hear more details on some of the Motus systems and other DB lab presentations this weekend. This is really just a tease. So adopting the Motus system to include mini Motus has proven an invaluable complement to traditional VHF tracking in advancing our understanding of bat behavior through selection and their interactions with the landscape in Ontario. Thank you. Yes, that's a good question. So the question was, how many mini Motus stations do you need to make it worth it for a project? And unfortunately, my answer is going to be, it depends. But it depends on the ecology of the system you're looking at. So let's just say you found a roost. It would be probably beneficial to go on all around the roost kind of thing, so you're not missing something on one end and not the other. But then also, maybe you're doing something like Aaliyah's doing. She's looking at a particular building. She might be only 4 to 6 mini Motus, but she can like circle that building with mini Motus and still get the directionality as they're leaving that roost. So it depends. Like a town, trying to think about the size of the town without giving it away, but like a town maybe the size of, I don't know, Perry Sound, say, you would probably need maybe 25 to 30 minutes of mini Motus stations to set up in like a grid-like formation to look at different roost movements and stuff. You'd also have to have an idea about some of the ecology of the bats in this particular area. Hope that helps a bit. Yes?
How fine would you go? At a certain point, if the mini Motus stations are too close together, they're all just going to overlap. So what's the
Very true. So yeah, so that's some of the work that Lisa was doing with the calibration, and Leah's following up on now with her circling of this anthropogenic structure. And I don't think they've come into too many issues yet in terms of overlapping detection frequencies in a way that isn't helpful. So like for the setup that Leah had, where she's got 2 antennas that are kind of like pointing out the same way. If you get bats on both of those, like you can still get the directionality from those. So I don't think I would recommend ever like putting them right next to each other, but they can be quite close. Thank you so much.